Here are some review problems for the final exam in 2019. This video will be numbers 1 through 20. So we're going to start with number 1, solve the absolute value equation. It's the absolute value of 4a plus 4 equals 5. So when we have the absolute value, we know that what's inside the absolute value could equal positive 5. But what's inside could also equal negative 5. So we set two equations, one equal to positive 5 and one equal to negative 5. And then we solve. So we get 4a equals 1, and a is 1/4. And then, oops, I copied that wrong. It should be a 4. Minus 4. And 4a equals negative 9. So a is 9/4. And then we can write it in this set notation 1/4 and 9/4. With the curly braces, it means those are our two answers. So that's number 1. Number 2 is an absolute value inequality. That's the absolute value of g plus 1 is greater than 9. Well, when we looked at the greater thans, we want more than 9 away from 0. So that was greater than 9, or it was less than negative 9. So we write our two inequalities, g plus 1 is greater than 9, or g plus 1 has to be less than negative 9, and that will give you an absolute value that's greater than 9. And then you can solve them. G is greater than 8, or g is less than negative 10. And in our set notation, it looks like this, g such that g is less than negative 10, or you could use the u, g is greater than 8. And that's your answer for number 2. In interval notation, I don't think we put that on there, but it would be a open parentheses 8 comma infinity, or regular parentheses. The bracket is for when it's equal to, or, and then parentheses negative 10, oops, that's a 10, and then negative infinity. So that's what your interval notation would look like. There's not interval notation on the final, but that's a good little review for you, in case you might be taking a June administration of the SAT. Number 3, absolute value of z minus 3 less than or equal to 2. So again, absolute value is distance from 0. So we want less than 2 or equal to 2 away from 0. So you're looking at numbers that are less than 2 and numbers that are greater than negative 2. So we write that between statement, negative 2 less than or equal to z minus 3 less than or equal to 2. And then we solve whatever we do to the middle, we do to both the right and the left. So we get 1 less than or equal to z less than or equal to 5. And then we can put that in our set notation with curly braces and define our variable. Or our interval notation would be bracket 1 comma 5 bracket, because they're both equal to. Let's see. Number 4, graph the function defined by y equals the absolute value of negative x plus 6. So let's move this up, and we get y equals the absolute value of negative x plus 6. Well, this equation, my vertex, is always going to be what makes the inside 0. So let's look at negative x plus 6 equal to 0. Subtract your 6, negative x equals negative 6, so x equals positive 6. And there's no plus k out here, so this is actually plus 0. And so my vertex is at 6, 0. And it's at positive 6, because if you look at your h would be negative 6, but the negative in front of the x makes it a reflection on the y-axis. That's why it's over at positive 6. And then we have a slope of 1. So from here, we're just going to go up 1 over 1, up 1 over 1, and make our v. If the negative was on the outside of the absolute value, it would be upside down. without using graphic technology, sketch the parent graph and translate it to obtain the graph of y plus 5 equals the absolute value of x plus 4. So I'm going to make this y equals the absolute value of x plus 4 minus 5, subtracting 5 from both sides. The parent graph is y equals the absolute value of x. So that's just at 0, 0, up 1 over 1, like this. And what does this graph do? The 4, right, that's going to move it, plus 4 moves it left 4, and the negative 5 moves it down 5. So the whole graph is going to go to here, and then still up 1 over 1. 1 over 1. But there is no vertical shrink or stretch or horizontal shrink or stretch. Number 6. Which order triple is a solution to the system of equations? We have negative 6x. Sorry, let me go to a black pen. So we are going to, if I look at these equations, let me bring these over here and make them bigger. There we go. So when I look at my x, my y, and my z, it looks to me like the easiest thing that's going to be to do is to eliminate my y's, because 2, 4, and 8 are all multiples of each other. So I'm going to multiply the middle equation by a negative 2 so that my y will eliminate with the top equation. So I have negative 6x plus 4y plus 6z. Okay, that equals 19. Now we're going to multiply the second equation by the negative 2, so I get negative 8x minus 4y minus 4z equals negative 2. And we get negative 14x. The y's cancel, that was the whole goal. 4 minus 4 is 0. Plus 2z equals 17. That's our equation 4. Then we're going to do equation 3, 8x. That's a plus 8y minus 4z equals negative 6. And I'm going to multiply the top equation by a negative 2. So I get positive 12x, because of negative negative, minus 8y minus 12z equals negative 38. So we have 20x. Again, my y's cancel. I want to make sure I eliminate the same y's. And then I get minus 16 z equals negative 44. So now I'm going to multiply this equation to get rid of the z's by an 8. So 8 times negative 14 is negative 112x plus 16z, and 17 times 8 is 136. And then let's put that together with 20x minus 16z equals negative 44. So we get 136 minus 44 is 92, and 112x minus 20 is negative 92x. The z's cancel, equals 92 divided by negative 92, so x equals negative 1, negative 92. So that leaves, in our answer choices, it eliminates B and D. So now we need to find out, looks to me like Z, the only choice here is 3/2. So the question is, what is your Y? So if we go back, let's see, we need to plug this back in to one of the 4 and 5 equations. Negative 14 times negative 1 plus 2 times z equals 17. And that's 14 plus 2z equals 17 minus the 14. 2z equals 3, so z is 3/2, just like it says in the other answer choices. And then lastly, I'm going to plug it back in the top. Let's plug it into the middle equation. 4 times -1 plus 2y plus 2 times 3/2 equals 1. So -4 plus 2y, 2 times 3/2 is just 3, equals 1. That's -1, because -4 plus 3 is -1 plus 2y equals 1. Add 1, 2y equals 2, so y equals 1, positive 1. So that makes the correct answer A. Now, of course, if you get how to do this, you could plug in, remember to check if they're solutions. You could plug in each and every point, but you have to plug the x, y, and z into all three equations, and it has to work for all three equations in order for it to be a solution. And the last one in this set is graphing y equals -1/4 x squared. So that's going to be a parabola. We should know. This is a multiple choice test, so if there's not a parabola, that one you can eliminate. This one is x, y. It's -1/4, so it opens down. And I'm just going to plug in -2, 0, and +2. And when I plug in 0, I get 0. When I plug in -2, I get -1/4 times -2 squared. So that is... can't move that out of the way. Let me erase some of this. -2, which is -1/4 times 4, -1. And then -1/4 times 2 squared is also -1/4 times 4. Remember that you're going to do the exponent before you can do the multiply. So that's -1. So I'm 0, 0, and at -2, -1, +2, -1. And this is a parabola that opens down, and it's pretty wide. Okay, next set, problems. Graph y equals -3x squared plus x plus 1. This is in standard form. So you want to -3x squared plus x plus 1. What are the key features we know about this? This equation opens down. We know that because of the -3. This equation has a y-intercept of 0, 1. With that information, you could probably eliminate half of the graphs. Now the vertex equation is -b/2a, which is -1 over 2 times -3. So my vertex is at +1/6. That's the x. So your vertex should be in the positive side of the axis, and then you can pick some numbers if you still need to look at that graph. But right now, we know that we have the point 0, 1, and my vertex is here at 1/6, so it's probably just above that. And then, if that's 1, it's going to look something like this. If I want to make a table, I can. I have 1/6 in the middle. I know it's 0, 1. I can plug in 1, -3 times 1 squared plus 1 plus 1. That's -3 plus 2, which is -1. So 1 down here is at -1. And then I could plug in -1, -3 times -1 squared plus -1 plus 1. That's -3 minus 1 plus 1, which is -3. So over here, it would be this point there. So once you have a couple of points on a multiple choice test, you should be able to eliminate the ones that are not correct by knowing that it opens down, knowing that the the y-intercept is +1, and knowing that the vertex is in the positives. If you still have two choices left after all of that, then you plug in a couple numbers and see which one is correct. I went too far. Let's look at the next one. Graph y equals -x minus 3 squared minus 1. Again, that's a multiple choice test here. So what do we know? X minus 3 squared minus 1. It opens down. Usually that eliminates about half of your choices. It has a vertex of +3, -1. And then if that information doesn't eliminate anything else, plug in a point. Let's plug in 0. Y equals -0 minus 3 squared minus 1. So -9. -3 squared is 9 times the negative, -10. So at 0, it should be -10. Those pieces of information should give you enough to have a pretty good idea of what this graph looks like. Let's see, we have 1, 2, 3, 3, -1, and 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so this point should be 6, 10 because of the symmetry. Remember, the line of symmetry goes through the vertex. And the next problem, how would you translate the graph of -x squared to reduce the graph of y equals -x minus 6 squared? So notice that the negative is already here, right? The negative's already here, so it's not asking about reflecting it in the x-axis. But this -6 translates it which direction? To the right 6. Remember, when it's inside the function, it's opposite. Number 11, graph the function. Oops, I don't want to do that. Hold on. Just erase some of my problems. Graph this function. It's in intercept form. So again, let's look at what we can determine from this. We've got negative, that means opens down. We have intercepts at -2, 0, and -5, 0. So that right there, -2, 0, -5, 0, it's going to open down. Halfway between -2 and -5 is 3.5. So your vertex is at -3.5, because that's the halfway point. And let's see how far up it goes. -2, -3.5 plus 2 times -3.5 plus 5. So -2 times -1.5 times +1.5. And since you get calculators, that's a +4.5. So up here would be your vertex. But just knowing your intercepts and whether it opens up or down should be enough to get you the correct graph on a multiple choice test. Same thing for number 12. Y equals -3, opens down. Vertex it, or intercepts at -5, 0 and -4, 0. So your vertex is halfway between -5 and -4, so your vertex there is at -4.5. So far, 1, 2, 3, 4, 5, and your vertex isn't going to be much higher. So negative 3 times negative 4.5 plus 5 times negative 4.5 plus 4, so negative 3 times 0.5 times negative 0.5, and that's 0.25 times 3 is 0.75, and it's positive. So that would be just barely above it, opening down. And then number 13 is kind of lost around here. Let's see. Y equals x plus 2 squared minus 2. It opens up at a vertex negative 2, negative 2. And then if I plug in 0, let's see, 0 plus 2 squared minus 2. So 2 squared is 4. So 0, comma 2 is my y-intercept. That information, let's see, negative 2 is my vertex. It opens up, it crosses the y-axis at positive 2. So my axis of symmetry is here, so I have another point on this side at positive 2, 2 away from the vertex, and that gives me my parabola. So factor the expression, what numbers multiply to 48 and add to 14. So let's see, positive 48 and 14. 48 is 6 times 8, 12 times 4, 16 times 3, 24 times 2. Which of these can add to 14? It's 6 and 8, so x plus 6 and x plus 6 and x plus 8. It's just asking you to factor, not solve, so you're looking for the factors. Now, what are the solutions? Now we have to solve. We need to get it on one side. X squared minus 9x plus 14 equals 0. What two numbers multiply to positive 14 and add to negative 9? We have x minus 7 and x minus 2 equals 0. Those multiply to negative, or add to negative 9 and add to positive 14, and then set each one equal to 0. X minus 7 equals 0. So x is positive 7, and x minus 2 equals 0, and positive 2. Again, solve using factoring. What two numbers multiply to negative 8, add to negative 2? X minus 6. No, that's not right. 6. X minus 4 and x plus 2 equals 0. So x equals 4 and negative 2. Number 17, factor the expression. Now this is our guess and check model where we have to say, okay, 36 is 9 times 4, 6 times 6. Let's start with those. There's other ones, but those will probably work for us. Let's try 6 times 6 first. So 6x and 6x. We know that our firsts are going to equal to 36x squared. And our last need to multiply to 28. That's 7 and 4, or 2 times 14. So let's try 7 and 4. Everything's positive, so means these are all going to be positive. We get 28 and 42. That adds to 42. Oh, no, not 24. Not 28. 24 and 42. That gives me 66, which is not 79. We need them to add to 79. So that one's not going to work. Let's try 2 and 14. 14 and 2. That's 12. 14 and 6. Is 84. Since everything's positive, I'm not going to be subtracting. This gives me 96. That's too big. So this one doesn't work. So let's try maybe the 9 and the 4. The 6 and the 6 didn't work with the two options I looked at. I don't think 28 and 1 is going to work, so let's try 9x and 4x with 4 and 7. We got 63 and 16. There we go. That adds to 79. So that works. They're both positive. So 9x plus 4 and 4x plus 7. Number 18, we should recognize right off the bat as a difference of squares. 68 is a perfect square, 9 is a perfect square. So 8x plus 3 times 8x minus 3. And number 19, solve. Again, we're going to have to use our guess and check. So 2x and 3x, or 6x and 1x. Those are the ways that we're going to get 6x, and 14 is 7 and 2, or 14 and 1. So let's try 7 and 2. We get 4x and 21x. I needed to add to negative 19, so 21 minus 4 is not going to give us 19. I could switch them. Let's switch them and see. Let's try 2 and 7, 14 and 6x. Those, if I add, are going to give me 20, and if I subtract, they're going to give me 8, so that's not going to work. So this doesn't work. I might try a different one, but let's maybe try 7 and 2. So 12 and 14. Or, no, sorry, not 14. 12 and 7. They both have to be negative. This is negative, this is positive. That means they're both negative. That would help me out if I thought about that before. And I get, there's our 19, negative 19. So that works. That's equals 0. So 6x minus 7 equals 0, x equals 7/6, and x minus 2 equals 0, positive 2. And lastly, when it says find the zeros, if y is a function of x, that means make that equal to 0 and solve it. So we're going to add the 35, and we get 4x squared plus 27x plus 35 equals 0. And we're going to factor, that's 2x and 2x. 35 is 5 and 7. Let's try that. I can get 10 and 14. That's only 24. Let's try 4x and x. 5 and 7. 20 and 7. That works. Plus equals 0. So we get negative 7/4 and negative 5 when I set each of them equal to 0. So remember that your goal is to make the firsts equal the first term when you multiply. The lasts will always equal the last term, the plus the 35. And the outside and the inside is what you're playing with. You're moving things around to make sure the outside and the inside are going to add to your middle x term. So here I have 20x plus 7x. So it's 27, which is what I wanted. If they're all positive, these are going to both be positive. If this is negative and this is positive, they're both going to be negative. If this is negative, then the bigger one is going to be the same sign as the what's on the inside here.